In this lecture, let's try to construct general relativity as a gauge theory. So first of all, let's talk about the conventions that I would be following. So throughout these lectures, I will use a metric signature of positive, negative, negative, and negative. And I would also be following the notations for the Riemann, Ricci, and scalar curvature, which are the following. So for the Riemann tensor, I'd be using this thing. Mu nu alpha is equal to partial mu gamma beta nu alpha minus partial nu gamma beta mu alpha plus gamma beta mu rho times gamma rho nu alpha minus gamma beta nu rho times gamma rho mu alpha. And by the way, this gamma, it's just the Levi-Civita connection or Christoffel symbols as well. And these things, they just come from your basic course on general relativity, right? And the Ricci tensor is simply R nu alpha, which is just R mu nu alpha, right? And then finally you have the scalar curvature, which is just G nu alpha, where this G nu alpha is the metric and times R nu alpha, right? So you just contract these indices and you get your scalar curvature, right? Now I'll also define something that is called the general relativity coupling constant as kappa, and which would be kappa squared is equal to 32 pi times g, where this g is general universal gravitation constant, the Newton's gravitational constant. Note that I will also be working in natural units throughout. That is, I would set C is equal to h bar is equal to 1 or unity, unless I mention otherwise some places. Right, now let's discuss some of the preliminaries. And let's start off by imagining for some time that Einstein had not existed. Now that is rude, but let's consider that for some time. And then if we wanted to build gravity from quantum field theory or quantum field theory reasonings, we would proceed as with theories with other interactions. We know from classical physics that Newton's potential, which is V, right, acting between two bodies of masses, say m1 and m2, is written as V of r is equal to minus g m1 times m2 over r. This is just from your basic classical physics, right? Now, this law out of the box is analogous to the Coulomb's interaction. And we know that the photon field serves as a mediator of the electromagnetic interaction, right? So then we can ask that, the question that we could ask is what would be the mediator of gravity, right? Because like we know for electromagnetic field, like I said, we know it's the photon. So, well, with a little inspection, it reveals that the mediator should actually be a particle with spin 0 or spin 2, but not spin 1, not spin 1. We don't even have that choice. And let's see why not spin 1 first. Let's address that question. So we know that since from electrodynamics, we already know that spin 1 particle, they lead to both repulsive and attractive interactions, right? But we know that, or we don't know any examples of repulsive gravity, right? And so we can get that out of the way. And higher spin particles, they cannot be consistently included in the quantum field theory framework, right? So therefore that leads us to the simplest option, which would be a Higgs-like force that is mediated by a spin 0 particle. So let's consider the interaction of a form that is this one, minus sum over all i's mi times 1 plus h over v times psi bar I times psi I. Now, for this interaction, we can find or deduce the potential by calculating the amplitude of a following scattering process, which could be this one over here, right? So I just had this in my clipboard, and well, I can write down the amplitude for such process as negative Im is equal to negative iota m1 over v times iota over q square minus m squared, and times the other part, that is minus iota m2 over v. Right? Okay, nice. So over here, Q is the momentum that is carried by this H particle, and M is simply its mass. Now, if I use Fourier analysis, we can get the potential from this amplitude, which would turn out to be V of R is equal to minus 1 over 4 pi V squared times m1 m2 exponential negative mr over r, right? Okay, now if I just take simply a limit, that is, if I say that my m goes to 0, I would recover the well-known Newton's gravitational potential, which I even wrote over here, this one, right? So this is what I would get back. Now, there are multiple reasons to why this choice of gravity is not going to work for us, right? So it's not going to work for us, or this choice of gravity mediator cannot be accepted. Let's start with what we know, that the bare mass of an object, right? A bare mass of an object is not the unique source of the gravitational field. Say or consider the constituent mass of constituent mass of proton. So let me write that here, which is P this T mu mu which is the electromagnetic the energy momentum tensor, sorry, and this thing is equal to P. This T mu mu can be written down as beta F squared, and I'll explain what this is, plus mass of the up quark times u bar u plus mass of down quark and d bar d, and we have P over here. Right. Now the overall contribution from the quarks is about 40 mega electron volts, and the rest of it comes from the effects of massless gluons, and the massless gluons are represented by this term over here. So this contributes to massless gluons, right? Okay. Next is that in nuclei, the binding energy gives an essential amount of contribution to the total mass. And also, if you think this way, that gravity is only sourced by masses, then photon, being massless, would not interact with gravity. Hence, we simply conclude that the source of gravity must be the total energy. So let me write this down over here. Source of gravity, it must be the total energy, which is represented by the energy momentum tensor EMT, which is TAB, right? Okay, now the next observation is based on the equality of inertial and gravitational masses, and from which we know the universality of the free fall, right? It follows from this equality between inertial and gravitational masses. So think of a pathway of a test particle in a gravitational field, which depends only on the initial position and the velocity of that particle. So in other words, what I'm saying is that the geodesic equation is independent of any of the quantities that depend on the internal composition of that particle. So whatever the particle is made up of. Moreover, if you recall the Einstein's equivalence principle, right, which partly claims the physical equivalence of freely falling frames with its generalization, which claims the equivalence of all coordinate frames. So the Einstein equivalence principle actually implies that for every observer at any moment of a proper time tau, one can choose a coordinate frame in which the gravitational field will simply vanish. So if I speak mathematically, all this means is that the Levi-Civita or the Christoffel symbols would vanish. So this thing mu rho is equal to 0. So particularly from the equivalence principle, it follows that the light must be bent by gravity in exactly the same manner as it is bent in the accelerating frames. Now let us try to account for this effect within the scalar gravity framework. So scalar gravity. Firstly, for the equivalence principle to even hold, we must firstly assume a universal coupling, which is the only way in which we can or the only way to couple the scalar field with the energy momentum tensor, and we can do it in this form, that this interaction Lagrangian is equal to this phi times TAA. Right? Now, if you recall from whatever course, I don't know, but for the electromagnetic field, or from your course on electrodynamics, right? The electromagnetic field, for an electromagnetic field, I can write this thing as, or it is somewhat equal to as E square minus B square, but we know that this E square minus B square is 0, and so hence the or we conclude from this is that the scalar gravity cannot even obey the equivalence principle, and so we conclude from this is that the gravity must be mediated by a spin 2 particle, or a spin 2 field to be exact, and that this TAB should be the source of this field, right? So the source of the field is the energy momentum tensor TAB, and the gravity is mediated by this spin 2 field. So it is mediated by the spin 2 field. Now, of course, we will get into the depth of this thing, but before we do, let us remind ourselves of some of the principles of this energy momentum tensor, right? So principles of the energy momentum tensor. Right. So let's consider an example, right, of a scalar field theory. Let's consider a real massive scalar field with a Lagrangian density that is equal to 1 by 2 eta AB, where this eta is of Minkowski metric, times partial A phi partial B phi minus 1 by 2 m square phi squared. Now, if I look at this Lagrangian, it is translationally invariant, and that translational invariance of this Lagrangian simply implies the existence of a conserved current. Conserved current. Now, I can write that as TAB is equal to partial L over partial times partial A phi times partial B phi minus eta AB times the Lagrangian density. Right. So, well, I can even write this down much more explicitly, and let's just do that. So that would be partial A phi partial B phi minus 1 by 2 common eta AB eta CD partial C phi times partial D phi minus m squared phi squared. Right. Now, from this, it just follows that, or using the equations of motion as well, we get this thing, that partial A T A B is equal to 0. Now, also note that what we can do is we can introduce charges over here as this H is equal to d3x of t00, so the 0 component of the energy momentum tensor, and pi is simply the integral d3x t0i components, and these charges are time independent. What that just means is that if I take the time derivative of h, I would get 0, and if I take the time derivative of pi, I would also get 0. Now, going back to a quantum field theory, we can derive the potential for a two-body graviton exchange. So let's just go down here, two-body graviton exchange. Now, the potential for such a system would be somewhat as 1/2 times 1/2, 1/2 times, it should be kappa by 2 TAB, 1 over 4 pi r times, again we would have a kappa by 2 and TAB, right? This thing. And if I simplify this thing, it would just become kappa square over 32 pi times m1 m2 over r. Now, remember what this kappa is just a constant which is telling you about the strength of the gravity coupling, right? So we see that considering the energy momentum tensor as a source of gravitational interaction, and the spin 2 field as a mediator of the gravitational interaction, it is pretty reasonable suggestion, right? So from here, next is what we want is to obtain this prescription from the first principles of quantum field theory. And so you'd leave that for the next part of this video.